Hey everybody, Mr. Plantt here, and today we are going to be reviewing how to kind of use these atom identification techniques to figure out things like number of protons, number of neutrons, mass number of electrons, all of that information. So in class we went over these first three, so I'm going to go over them again real quick and just kind of give you a reference on how we find these information. Okay, so first off, we're going to start with this atomic symbol Ga. And so right now, all we can do to figure out the nuclear symbol, well, we know that it's going to be Ga again. And then in the top left corner is going to be this mass number. Remember, that mass number is telling us the isotope of gallium that we're dealing with. An isotope has a different number of neutrons, but it's the same element. So now we're dealing with a specific type of gallium, gallium-70. This is really important because we want to trust in our chart's mass number over the periodic table. The periodic table, if we look at gallium, right, it says 69.72. That's because this is an average of all the different isotopes of gallium. So the periodic table is less accurate in this case. It's given us the most common, the average isotope of gallium, whereas the table we're working with, this chart, is giving us the specific isotope. So we always want to use the more specific answer when possible. Okay, so let's go back to our periodic table. And we look at gallium, and now we need the atomic number. And that's this number up above, right? If we look at our key, atomic number equals the number of protons. So we have 31 gallium. Okay, so atomic number 31. And what I wrote on there, right, is that the atomic number is always equal to the number of protons. It's because an element is dependent on the number of protons, what type of element it is. So if we're looking at gallium, it will always have 31 atomic number and 31 protons. Always, which is pretty nice. Okay, neutrons. So in this case, we have protons, we're looking for neutrons, but we have our mass number. Now we need to go back in our notes and remember that mass number is equal to protons plus neutrons. So to figure out neutrons, we need to take our mass number and minus our number of protons, or our atomic number, since they're the same thing. So we have to do 70 minus 31, and that gives us 39. 39 neutrons. Pretty cool. Okay, and we'll see as we do other ones, we get different numbers of neutrons because it's an isotope, right? The definition of an isotope is the same element with a different number of neutrons, a different atomic mass. Okay, last box in this row is the number of electrons. And to do this, we have to look at the charge. It tells us that the overall charge is 0, right? A 0 overall charge. That indicates that we have the same number of positive stuff as negative stuff. In this case, our positive stuff is the protons. Our negative stuff is the electrons. And so if we want those to equal out and get us a charge of 0, we need to have the same number. So if we have 31 protons, we need to have 31 electrons. Not so bad. So let's do another one. So this next one, okay, we have gallium again. So our atomic symbol is still Ga. Remember that lowercase second letter we need to use. Right? If we do two uppercases, now we're saying that it's two different elements. So we got to use the lowercase letter for the second letter. Okay, and we have gallium. In this case, we have gallium-74. So now it's an isotope of gallium that instead of having a mass number of 70 like before, it has a mass number of 74. Okay, it comes from that little corner. Not so bad. Now the nice part is, since it's still gallium, the atomic number is still 31, and the number of protons is still 31 because it's gallium. If it was, say, calcium, it would have 20 protons and the atomic number would be 20. If it was hydrogen, it'd have 1 proton and the atomic number would be 1. Right? That element will always have the same number of protons and the same atomic number. Okay, so we can go through the same process to find our number of neutrons, right? We have 74 mass number, 31 protons, and so we do 74 minus 31, and we end up with 43 neutrons. 43 neutrons. So notice we have 4 more. And that makes sense because our mass number has increased by 4. We know we can't increase the protons without changing the element. We can't change the number of electrons because that doesn't change the mass at all. So the only way to get our mass to increase by 4 is by adding 4 neutrons. Okay, last step now is to figure out this 3 plus or plus 3 charge right here. Okay, so this is telling us that our atom now overall has a positive 3 charge. Okay, now if we think about the things that can give charge, we have protons that give a positive charge, and we have electrons that give our negative charge. So the only way for us to get a positive 3 charge is by having 3 more protons than electrons. Okay, so if we have 3 more protons than electrons, we have 31 protons. That means we need to have 28 electrons. Okay, a way to kind of double check yourself, if you do protons minus electrons, so 31 minus 28, that should give you positive 3. If this was a negative 3, we could do protons 31 minus 34 electrons, and we would get a negative 3 to get an overall negative 3 charge. Okay, one last row real quick, and let's see what we get. So in this case, we're given number of protons, we're given number of neutrons, and we're given number of electrons. So we're going to start with the protons because that tells us the element. So number of protons tells us the atomic number, 31. And would you look at that? It's still gallium, right? 31, 31. So we know it's still Ga here. We don't know the atomic mass number yet. So we need to go find that so we can put it up here on our nuclear symbol. Quick note, right? Nuclear symbol just uses the atomic mass in the top left corner. An isotope symbol would have Ga dash, whatever are, in this case, Ga-70, Ga-74. They both tell you the same thing. It's just different ways of writing it. Okay, so to find our mass number now, we have to use our number of protons and our number of neutrons, because these are both the subatomic particles that have a meaningful mass. Right? We have protons that have a mass of 1, neutrons that have a mass of 1, and electrons that pretty much have a mass of 0 atomic mass units. Okay, so we have 31 plus 45. That gives us 76. Okay, so now we have another isotope of gallium, and this is gallium 76. Oh, that was a bad 6. So all 3 of these are gallium, but they're different versions of gallium. They're all different isotopes. And our last step is to find the charge. Now it gives us number of electrons, and it gives us number of protons. So we can do our little subtraction. 31 protons minus 28 electrons equals a positive 3. So our charge is still 3 plus. Now, if this was like 45, we could do 31 minus 45. It's kind of a big difference, but it's still possible, I guess. And we would get something like negative 14 charge. Right? That's probably not really all that possible. The atom structure couldn't sustain that, but you get the idea, right? That if the number is a positive number, it's a positive charge. If the subtraction ends in a negative number, it's a negative charge. All right, guys, I hope that helps you out as you finish working on this worksheet. Remember, you can message me or Mr. Armstrong on Remind for help at any time. We will try to get back to you as soon as possible. And keep working hard, guys. You're doing great. And I will see you next week.